This is 3.2, imaginary and complex numbers. So to start off, when we take the square root of a number, it's usually a number times itself. However, we have to know what happens when we try and take the square root of a negative number. And there is something that happens. It's more than just can't do it or no solution. The square root of -1 is defined as the imaginary number I. And so anytime we encounter the square root of a negative, our answer is going to have I in it somewhere. For example, the square root, whoops, there we go. The square root of -4 can be written as the square root of -1 times the square root of 4. The square root of 4 is 2, and the square root of -1 we just defined as I, and so our answer is 2I. And usually we write the I second after our number. Same thing with square root of -16. I can write square root of -16 as the square root of -1 times the square root of 16. The square root of -1 is I, and the square root of 16 is 4, so we get 4I. For the square root of 100, 100 is a perfect square, and then we've got a negative sign, so I'm going to go ahead and write this as the square root of 100 is 10, and the square root of the -1 is I. When we don't have a perfect square, like 18, we have to do a factor tree. So over to the side, I'm going to do a factor tree on positive 18. We already know the negative is I, so we need to deal with the positive. Well, 18 is 2 times 9, and 9 is 3 times 3. Those are all prime factors. So between 2, 3, and 3, I'm looking for a pair. I have a pair of 3s. And so I'm going to be able to write 3 square root of 2. And then when we write the I in between the whole number and the root. We're going to do the same thing with 48. Over here, I'm going to do a factor tree. So 48 is 2 times 24. 24 is 2 times 12. 12 is 2 times 6. And 6 is 2 times 3. So we have all of these prime numbers. So some 2's and a 3. I can create 1 pair of 2's and 2 pair of 2's. So that means for my answer, I'm going to have 2 times 2. I'm going to have square root of 3 because of the extra 3 that didn't have a pair. And then because of the negative, I'm going to have an I. So that's going to give me 4I root 3. I'll do the same thing for 72. So let me scroll up a little bit so I have some room. And I'll do a factor tree on 72. So 72 is a little big, so I can hop over to Desmos. And I can let Desmos be used as a calculator. And type in what it will let me. 72 divided by 2 and get 36. So I'm going to do 2 times 36. 36 is still even, so it's 2 times 18. 18 is 2 times 9. And 9 is 3 times 3. So I've got all of these prime numbers at the bottom of my factor tree. I'm looking for pairs. So I have a pair of 2's. I also have a pair of 3's, and I have an extra 2 that I don't want to forget about. So when I write this answer, I'm going to say 2 for my pair of 2's times a 3 for my pair of 3's, an I for my negative sign, and then square root of 2 for the extra 2 that didn't have a pair. So 6I root 2. I'll do the same thing for 75. Let me do that factor tree right down here. So 75 doesn't divide by 2, but I notice that I can think of like quarters, like 75 cents. So this is 3 times 25, 3 quarters. And then 25 is 5 times 5. These are all prime numbers. And I'm looking for a pair. I have a pair of 5s. So I'm going to have 5 for my pair of 5s, an I for the negative sign under the radical, and a square root of 3 for the 3 that didn't have a pair. So we can actually count in the imaginary number system. So just like we count 1, 2, 3, 4, 5, 6, we can count in imaginary numbers. So I, we already established, was the square root of -1. I squared then is the square root of -1 squared. Well, we learned in the last section that if you square a square root, they cancel each other out. So I squared is -1. For I cubed, we're going to do I squared times I. Well, I squared was -1, so we're doing -1 times I, which means we've got negative I. Let me highlight these guys. So that and that. And that one's important too. Then for I to the 4th, let's do I squared times I squared. Well, that's -1 times -1, which is +1. After that, the pattern actually repeats because I to the 5th can be written as I times I to the 4th. That gives me 5 I's, I to the 5th. And I to the 5th, because we write it that way, we've got I times I to the 4th, which is 1, and 1 times I is I. So we're back where we started off. Let me highlight that in purple. For I to the 6th, we're going to do I times I to the 5th. So we're multiplying by one more I to get I to the 6th. I, we're going to leave as I to the 5th is I, and I times I is I squared, and we learned above that I squared was -1. So if this pattern is repeating, that means that I to the 7th is going to be the same as I to the 3rd. So I to the 5th was the same as I, which is where we started up here at the top. I to the 6th was the same as I to the 2nd, which was this -1 right here. So then the next one is actually going to be I to the 7th is going to be the same as I to the 3rd, which is -I. And I to the 8th is going to be the same as I to the 4th, which is +1. So one way to look at this is as a circle. And on that circle, we have 1 I squared, and I cubed. And let me actually write I to the 4th up here. So I is our square root of -1. I squared is -1. I cubed is -I. And I to the 4th is 1. And we can let this pattern repeat as we go to higher exponents. So for I to the 13th, the next example, we could start with I to the 1st and do 1, 2, and I'm just counting around, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 takes us around to I. What some people like to do is they like to do a little bit of division. So I'm going to do 13 divided by 4. So let me pull up my calculator in Desmos and do 13 divided by 4. When I do this, I look at the decimal after the decimal point. So I see 0.25. If your I is equivalent to I to the first, your decimal is going to end in a 0.25. So because we got something 0.25, what was it? 3.25. We look at the 0.25, and that gives us I. For 24, we could count all the way around, or we could say 24 divided by 4. And we're always going to divide by 4 every single time. So I'll make a little note by this. Divide exponent by 4. And 24 divided by 4 is 6, but the decimal is 0.00. When the decimal is 0.00, that looks like 4.00. Let me move it. Then your I is equivalent to I to the 4th, or positive 1. So let's try 38. So for 38, I'm going to do 38 divided by 4. I'm going to go over to my calculator and do 38 divided by 4. I get 9.5. When your decimal ends in a 0.5, that means that you're down here with I squared, or negative 1. And then let's try 50. So 50 divided by 4. And I'll go over to my calculator and do 50 divided by 4 and get 12.5. So there's another 0.5. And because it ends in a 0.5, it's the same as I squared, which means negative 1. The last one over here is 0.75. So it's like counting quarters. So if it's 0.25, you put down I. If it's 0.5, you put down negative 1. If it's 0.75, you put down negative I. And if it's 0.0, you put down 1. We can also work with complex numbers that have I in it and do some multiplication, addition, and addition. So we're going to, when we have a number in front, do what we would normally do with a number in front. We're going to distribute. So I'm going to do 4 times 3 is 12, 5 times 4 is 20, and just attach my I. Same thing with the negative 5, just a number sitting in front of parentheses. I'm going to multiply, so negative 5 times 1 is negative 5. Negative 5 times negative 6 is positive 30, and we'll just attach the I. When you add, you want to combine like terms. So what I'm going to do here is I'm going to find the terms that have I's attached and separate them from the ones that don't have I's attached. So I see 2 terms. I see the 2 and the 4, and I'm going to add them because they don't have I's. And then I'm going to take the minus 2i and the minus 5i, or I guess it's a positive 5i, and I'm going to combine them to get 3i. And then my answer is going to be the 6 plus 3i. Same with the next one. I'm going to find my non-I terms. So I've got a 1 and a 3 that don't have an I. And then I'm going to find my terms that have i's. So I have an I plus negative 2i, which is going to give me negative I. And so my answer is going to be 4 minus I. I can do the same thing with subtraction, but what I would recommend you do is take that minus sign and distribute it first. So make this 8 minus 10i minus 4 minus 3i. And then combine your i's and your non-i's. So my non-i's are 8 and minus 4, so that's going to get me 4. And then I've got negative 10 and minus 3, which is negative 13, with the I attached. Same thing with the next one. I'm going to distribute my minus sign so I don't lose it. So I've got 4 plus I minus 2 minus 6i. My non-I terms are 4 and minus 2, so 4 minus 2 is 2. And then I minus 6i, so that's going to be 1 minus 6 is negative 5i. And you're combining those I terms just like you would like terms with x's. So it's just a different letter. For the next 4, we're multiplying two binomials together. They have 2 terms in each of them. So there's 2 terms in the first set of parentheses and 2 terms in the second set of parentheses. So we have to make sure each term in the first set of parentheses gets multiplied by each term in the second set of parentheses. To do this, I have a little bit of a graphic organizer. So what I'm going to do for the first one is I'm going to draw myself a box with 4 quadrants. Across the top, I'm going to take the 3 plus 2i. I'm going to put the 3 above the first column and the plus 2i above the second column. And then I'm going to take the 4 and the plus I and write them down the side. Then what I'm going to do is I'm going to multiply, kind of like a multiplication chart, to get the values in each of the quadrants. So I'm going to start with the upper left, and I'm going to do 4 times 3, because those are the ones touching it, so that's 12. For the upper right, I'm going to do 4 times 2i, so 8i. Lower left, I'm going to do 3 times I, so 3i. And then lower right, I'm going to do 2i times I. Well, 2i times I is 2i squared. And 2i squared, if you remember from the first page, is the same as 2 times negative 1, which is negative 2. So I'm going to leave that in that box. Then when I take these out of the box, I'm going to add them together. So I'm going to start with the 12, and I'm going to say 12 plus 8i plus 3i plus negative 2. And then I'm going to look for my non-I terms. So 12 and negative 2 gets me 10. And then 8i plus 3i, that's 8, 9, 10, 11, gets me 11i. I'm going to do that with the next example. So I'm going to set up 5 minus 9i and 7 minus I along the top and the side. Then I'm going to do 7 times 5, which is 35. 7 times 9, and it's negative, so that's going to be negative 63i. 5 times negative I is negative 5I. And negative 9I times negative I is going to be a positive 9I squared. So I'm going to take that 9I squared, I'm going to make that I squared a negative 1 using our rules from the other page, which gives me negative 9 for that box. Then I'm going to add, so I'm going to do 35 minus 63I minus 5I minus 9. And those are all adding a negative, so we can just make them a negative. 35 minus 9 is 26. And then negative 63 minus 5 is negative 68 with an I attached. So you can use the box if you want to. If you don't want to, you can do something called double distribution. And so what I'm going to do is I'm going to take each term in the first parenthesis and distribute it to the other parenthesis. So I'm going to start with 3 times 1, which is 3, and 3 times I, which is 3I. And then I'm going to do the same thing with the negative 6I. I'm going to distribute it to both terms in the second set of parentheses. So I'm going to have negative 6I times 1, and then negative 6I times I, and I times I is I squared. I can go ahead and combine the i's by making that 3 minus 6 is negative 3I. The I squared becomes negative 1, just like we were doing before. So I've got 3 minus 3I plus 6. 6 plus 3 is 9, so we've got 9 minus 3I. And again, same thing with the last example here. I'm going to double distribute, so I'm going to distribute the 10 and get 40 minus 40I, and then I'm going to distribute the 6I and get 24I minus 6 times 4 is also 24I squared. And I'm going to simplify, so I'm going to say 40. Then we're going to have negative 40 minus 24, so that's going to be negative 26I. 40, nope, got that right, 16. And then minus 24 times negative 1. We're going to make that I squared a negative 1 all the time. So we've got 40 minus 16I plus 24. And 40 plus 24 is 64. And then minus 16I. So we can take all of this knowledge about complex numbers and imaginary numbers, and we can solve equations like we did in 3.1, but with complex solutions. So this first example looks like what we did in 3.1, and so we're going to start off the same way. We're going to take the square root of both sides, except this time when we take the square root of both sides, not only do we have an 18, but we also have a negative. So I'm going to do a factor tree on 18 right here in the margin. So 2 times 9 and 3 times 3. And I see I have a pair of 3's. So I'm going to write down square root of x squared is x equals, and don't forget your plus or minus like I did. I'm going to have a 3 because of the pair of 3's, an I because of the negative, and a square root of 2 because of this extra 2 that we have right here that didn't have a pair. So the only difference in these problems is you have to look out for that negative sign that tells you that you have to use an I in your answer. So we can do the same thing here. I'm going to divide by negative 8 and get x squared equals, Let's see, 32 divided by -8 is -4. So I'm going to take the square root of x squared equals plus or minus the square root of -4. 4 is a perfect square. It's 2, so we're going to have plus or minus 2, and then an I for the negative sign. For the next example, I'm going to have to take the square root of both sides first to get rid of that parenthesis. So that means I'm going to have x minus 3 equals plus or minus square root of -28. Let me do a factor tree on 28 and do 2 times 14, and 14 is 2 times 7. I have a pair of 2's, so I'm going to have x minus 3 equals plus or minus a 2 for my pair of 2's, an I for my negative sign, and a square root of 7 for the extra 7 that didn't have a partner. Then I'm going to add this last 3. And remember that last number that we add goes in front of the plus or minus. So I'm going to do 3 plus or minus 2i square root of 7. Next example, I'm going to subtract 10 because that's outside the square root. So I've got x plus 5 squared equals -21. I'm going to take the square root of both sides and get x plus 5 equals plus or minus square root of -21. 21 does factor into 3 times 7, but it doesn't have a pair. So if it doesn't have a pair, it's going to stay a square root of 21. The only thing we're going to do to it is we're going to go ahead and make it plus or minus, and we're going to put an I instead of the negative sign. Then we'll subtract 5. And remember that 5 goes in front of the plus or minus, so we're going to say x equals -5 plus or minus I square root of 21. Few more examples. So for the next one, we'll start by subtracting 4 and get x plus 1 squared equals -2. We'll take the square root of both sides and put x plus 1 equals, don't forget your plus or minus, square root of -2. I'm going to take the square root of -2. -2 has a negative sign, but it's not a perfect square. So we're just going to write plus or minus I root 2. And then subtract the 1. Remember, put that 1 in front of the plus or minus. So -1 plus or minus I square root of 2. For the next one, I've got a -4 out front. So I'm going to divide by a -4 and get x minus 7 squared equals -10. Take the square root of both sides and get x minus 7 equals, let's try and do the I in the same step. So we're going to have plus or minus I square root of 10. I can do a factor tree on 10, but I get 2 and 5, so I don't get any pairs. So I'm going to go ahead and add the 7. Remember to put that 7 in front of the plus or minus. So 7 plus or minus I square root of 10. Last two examples. We've got a little bit of everything and a fraction at the end. So I'm going to subtract the 10 first because addition and subtraction moves first. That's going to give me 5 times x minus 6 squared equals -25. Then I'm going to divide by the 5 that's outside. and get x minus 6 squared equals -5. Take the square root to get rid of the parentheses and the squared. So x minus 6 equals plus or minus, let's deal with the negative sign. So we're going to have I square root of 5. And then we're going to add 6 and get x equals 6 plus or minus I square root of 5. For this next one, we've got a 1/2 multiplying and we've got a 6 adding. So we're going to move the 6 first, just like normal. So minus 6. So we've got 1/2 x plus 8 squared equals -2. To get rid of a fraction, what I like to do is look for the bottom number and always multiply by the bottom number first. So the bottom number is 2. So I'm going to multiply both sides by 2. And I'm going to say x plus 8 squared equals -4. Take the square root and get x plus 8 equals plus or minus, because I took the square root, I because of the negative, and I'm actually going to leave myself a little room because 4 is a perfect square, so I can go ahead and write 2i. And then I'm going to subtract the 8. Don't be fooled when you subtract the 8. Put that minus 8 in front of the plus or minus. So -8 plus or minus 2i.